On a cumulative record, the y-axis value of any data point represents the number of responses recorded at that time. B, the y-axis value of any data point represents the total number of responses recorded since the beginning of data collection. C, the y-axis value and the x-axis are equally distributed in space and time. Or D, the data path cannot reset to 0. The correct answer is B. The y-axis value of any data point represents the total number of responses recorded since the beginning of data collection. So the y-axis value and the x-axis are equally distributed in space and time. That's actually not true. Typically, the y-axis is much shorter than the x-axis. So there is no equal distribution on a cumulative record. I thought that the trickiest one is actually D. The data path cannot reset to 0, because most people think that on a cumulative record, it actually cannot reset to 0, and that's not true. Cumulative records often do reset to 0 if there's some change in condition. You'll see somebody drop that to 0. You also, if cumulative records pass a certain threshold on the y-axis, a lot of times they'll reset to 0 there too. It can happen. So I thought that one was the hardest one. So A, I think is easy to say no to, because the y-axis value of any data point represents the number of responses recorded at that time. It's literally called cumulative record. It is cumulative by nature. So it's not going to be at that time. And then C, the y-axis value and x-axis value are equally distributed in space and time. That's just not true of a cumulative record. Oftentimes you will have a much shorter y-axis than x-axis. So then it's tough to choose between B and D, but hopefully when answering a question like this, you know that it is possible to reset to 0, or at the very least, you can look at the language in D where it says cannot reset to 0. It makes it where that has to be true 100% of the time for us to choose that answer. And that just isn't the case. We're left with the correct answer, which is B. The x-axis value of any data point represents the total number of responses recorded since the beginning of data collection. So on a cumulative record, the number of responses recorded and added is recorded and added to the total number of responses recorded during previous observations. This is why it's called cumulative, because we're always adding it to what we've already observed. So the y-axis, or vertical axis, represents the total number of responses recorded since the start of the data collection. Unless, of course, we reset it to 0, and then it would be the total number since that reset. An important note that anytime that responses aren't occurring, you're going to get a flat line. So essentially, there's going to be no slope to the cumulative record line. A cumulative record displays the total number of responses at any given point of time. Essentially, the steeper the slope, the higher the response rate. This can be true of the overall response rate. And then we also can look at the local response rate to see how responses are changing closer to the data point that we're looking specifically at. So again, the steeper the slope, the higher the response rate. And when there was no slope at all, that means there were no responses during those days. This is me asking for reinforcement. Well, potential reinforcement.